Hi, my name is Eli Dodon. I'm here to talk to you about echolocation and communication. So, what is echolocation? Echolocation is when an animal is able to detect an obstacle or potential prey in front of them by shooting sound waves and seeing where these sound waves bounce off of, basically. When they get feedback, they're able to triangulate where the object is, and they don't just shoot one sound wave, they shoot a multitude of them while they're flying, while they're moving. And when the sound waves bounce off of that specific object, they come back to the animal in question and they're able to see how big the animal is, how small, the size. I mean, I just said the size of it. How big, how small, if it's moving, if it's not. And then they're able to, eat it or not. Because this is a predatory skill, and we'll get into that soon. Its adaptive value. Echolocation is vital to the survival of animals because, it helps them find prey. I just said that. Communication aspect. They can also use echolocation to talk to one another as well. It's not just for looking for prey. So they can communicate to one another, and then they can kind of tell each other where the prey is, where it's gonna be, because all these animals like to hunt in packs usually, except the last animal in question, and we'll get to that towards the end. Um, those birds actually hunt alone, so that's like the outlier compared to the rest. So the first echolocation animal is the bat. There's 70% of bat species use echolocation, so not all of them. And the cute little fruit fly ones, they don't use echolocation because they have pretty good eyesight. So echolocation is used for insect hunting. It's a way to um, look for food, hunt for prey. They mainly use it because they have poor eyesight. They evolved without when they didn't have any wings. They evolved the use of echolocation because they had very poor eyesight and they just hunted for insects. Um, and then once they grew wings through evolution, they still continued to carry on the echolocation uh, trait. But yeah, echolocation is their main way of seeing and hearing as well, because their eyesight is pretty pretty garbage. Bats are nocturnal. They live in caves. They live in packs in caves together, and they very rarely venture out of the cave. The way they get food is when an insect travels into the cave, and when an insect travels into the cave, it's most likely not going to come out alive because there are so many bats that live together all at once in packs basically. And it's like hundreds of thousands of bats like actually in one cave. They just like hang on the ceiling like a generic bat. It's like it's true that they sleep upside down. So the cost of echolocation in bats is that since they have poor eyesight, so that's their cost, I believe. And their benefit is that they can have teamwork and they use hunting parties to find insects to bring back to the rest of the group. I actually have a video to showcase that how echolocation sounds. It might sound a little bit weird because echolocation in bats is very high pitched, so it can't be heard by the naked human ear. So this video that I found kind of slows down the sound and makes it hearable for humans. I have the video pulled up right here.
A bat produces extremely high-pitched sounds in its throat and then projects them forward. We have slowed the sounds down, but can still only hear them by converting them to lower frequencies. They bounce off the walls as echoes and are detected by the bat's huge ears. These are in constant movement and enable the bat to map its surroundings with remarkable precision.
So that video showcases the echolocation of a bat. One thing I completely forgot to say that the maladaptive environments of a bat would probably be environments that are out in the open, outside of caves. For no sound waves can bounce off of walls in those environments. So bats usually spend 90% of their lifespan inside of a cave, and they rarely venture outside of it. So yeah, the next animal is a dolphin. Dolphins are found in the Atlantic and Pacific Oceans, and they evolved the use of echolocation to find schools of fish. So they use echolocation in kind of the same way. They use the echolocation to look for prey. However, they live on the coasts um, of oceans, and when they go and look for food, they go into the deeper depths of the ocean where eyesight is not really used, and they use echolocation in those scenarios to find fish because it's so dark. They don't use their eyes; they use echolocation. So the way dolphins use echolocation to find fish is that they push air through their nasal sacs and into their forehead, called the melon, and then this creates a clicking sound and creates sound waves. If you are underwater when you hear this, you'll be able to hear some clicking sounds, but sometimes you won't be able to. It's a little bit less high frequency than the bat, but it's still pretty high frequency. So the cost of this is that they have poor eyesight in deeper territories, and then the benefits, of course, is that they find lots of food because this echolocation helps them find schools of fish altogether. Their maladaptive environment would be near the coast because their food isn't really there, and echolocation isn't really used for coastal movement. They have pretty good eyes, so they use their eyesight when the water is kind of lit up, because when you get into the deeper territories, the light doesn't penetrate down there, so they mainly use echolocation for navigation and finding prey. So this next video I found, you'll be able to hear what it sounds like.
An organ called the melon, located on the dolphin's head, concentrates and amplifies these sound pulses and sends them forward. These sound waves travel through the melon and into the water, bouncing off nearby objects. The clicks or sound waves then return to the dolphin as echoes. The echoes are picked up by the dolphin's lower jaw and forehead, which work like antennas to receive the signals. From there, the signals are channeled through the ears and back into the brain. The brain can then interpret them, allowing the dolphin to see by using sound. This process is so precise that dolphins are able to determine the shape, size, speed, and direction of the objects around them. It can even determine the internal structure of some objects. At this point, you may be wondering how humans look to dolphins underwater. As our bodies consist mainly of water, we provide a prime target for echolocation. If a dolphin were to use echolocation on us, they would be able to see muscle, bone, and scar tissue, and even artificial body parts. This would be enough information for them to tell one human from another. So
So that's pretty cool, in my opinion. That's really cool. That's how they find food. They can differentiate between people. So yeah, that's the dolphin. Moving on to the oilbird. These are birds that are nocturnal, and they evolved echolocation because, just like the bat, it's a better method for vision in close range. Their eyes are actually quite good for long range distances, but up close they have a blind spot, and the echolocation helps them find food when they're flying around because they have to fly close to branches. Oilbirds are herbivores, so they don't eat insects or anything. They eat oily things. That's why they're called oilbirds. They eat palm oil. They eat avocados and avocado seeds off of trees, so that's avocado oil as well. Just lots of oily things. So they evolved this because um, they're just nocturnal animals. So over time, they needed a way to hunt while while it's pitch black at dark at night. Cost of this is poor eyesight, and benefits are lots of seeds and fruit because they're some of the only birds that eat at night, so they don't really have any competition except themselves. A maladaptive environment would probably be wide open trees with spread out areas because they do burrow in caves just like bats do during the day. So they sleep in caves during the day, and then at night they come out of the cave and they circle the trees around their cave. They don't really fly long distances. So yeah, these oil birds are actually one of the only animals you can hear their echolocation. Their frequency is much, much lower than a bat or a dolphin. So you can actually like verbally hear these screeches, and it's kind of just crazy. I also have a video of this. There's no video to it. It's kind of just audio, but yeah. So yeah, that's pretty crazy. I'm not gonna play the whole video because it's really long and it, kind of just sounds the same over and over again. Um, yeah, those are oil birds. They screech a ton, and they hunt together, so they have a screeching party, at times. So yeah, my topic guide for communication, the 3 topics I needed to cover. True communication. Is this true communication? I believe so because echolocation would be the signal in use, and others could understand what is being said as well, like their fellow animals. So like a bat could talk to another bat through echolocation, and dolphins as well. They hunt in packs. They're very social creatures. Like they hunt in pods. The dolphins, so they can use echolocation to talk to one another and also communicate to find fish. I also believe that this is an honest signal because honest signals are information that is being relayed accurately. So the sound waves are quite accurate to the person, and then they would use true communication to communicate with one another to say that, hey, the signal is accurate, let's go get this food. You know what I'm saying? So and lastly, the behavior is adaptive because echolocation would help increase the animal's fitness since it clearly relates to their survival. If they didn't have echolocation, then they wouldn't be able to survive because they wouldn't be able to get food from any other source because that's basically the way they see. So they'd be kind of in the dark, no pun intended. They'd be in the dark if they didn't have echolocation. So yeah, that's about it. These are my references. Thank you for watching this video. Really appreciate it. And yeah,